Now, you want to find out the left sum and the right sum of this function. Fx is 2x squared plus 1, okay, and on the interval 0 to 1 using 5 rectangles. You want to make 5 rectangles, we will use this value as the left sum and the right sum, okay, or the lower sum and upper sum. Okay, so how do I do that? So here, solution. So tell me what is A. A is the left side of the interval, which is, this is A, this is B, right? A is 0, B is 1. So tell me what will be delta x. What is the formula? B minus A over N. So how many rectangles you want to make? 5, right? So it is 1 minus 0 over 5. That is basically 1/5, or you want to write 0.2. That is the delta x. So each of this width will be 0.2, okay? So what you have to do here is to find out this left sum. Let's find out the left sum here. L equals to summation I runs from 0 to n minus 1. What is n? Let me write that n. So I equals to 1 through 0 n minus 1. That will be 5 minus 1 is 4. You see that? And delta x is 0.2. And then f of 0 plus I times 0.2, right? You see that? And then close that. So how that look like? So you write I runs from 0 to 2, 0 to 4. So this is I runs from 0 to 4, you see that? And then 0.2 times f of 0.2i, right? You see that? 0.2i. So what is fx though? So fx is 2x squared plus 1. So how do I write that? Is summation I runs from 0 to 4, right? And then I would write 0.2 times 2x. X is 0.2i, right? So 2 times 0.2i squared plus 1. You see that? So how do I write that one then? So let's simplify. Summation I runs from 0 to 4. You see that? 0.2 times. So how much is 2 times 0.2i times 0.2i? If you do 2 times 0.2i times 0.2i, it will be like 2 times 0.04i square. That's what you get. Because 0.2 times 0.2 is 0.04 and I square. And then plus 1. So what I'm going to do next is I runs from 0 to 4. And then just simplify this, okay? So 2.04 will be 0.08 times 0.2 will be 0.016, I think. So 0.016 I square. You see that? And then plus, how much is that? 0.02. 0.02. That's what you get. Okay, guys? Because it is 2.04 will be 0.08 times 0.2 will be 0.016, and there is I square and then plus 1, but you need to distribute that 0.2 to both of this one and that one. You got that one. Okay, so next what we do is we distribute the summation to both of those. So this will be this is equals to summation of 0.016 I square, okay, plus summation of I equals to 1 through 4, 0.02. You see that? So this will become, you pull that 1 through 4, right? So I runs from 1 through 4, 0.016. So this is I square. What is the formula for I square? It is n times n plus 1 times 2n plus 1 over what? N times n plus 1 plus 2n plus 1. Oh, I'm sorry. This is 0 through. Okay, so what do I do next is I just distribute this sum to this first term and then the second term. This is what you get, okay? 0 through 4, 0.016 I square plus, and the sum give to the second term I equals to 0 through 4, 0.02. What I'm doing next is I want to pull this to the front because this is a number, right? And then keep I square inside. So what do I get is this. So you get summation 0 through 4, I equals to 0 through 4 I square, and plus, so what is n? N is 5. Why? Because you are starting from 0, right? I equals 0 and then 1, 2, 3, 4. The total is 5. So it is, this is the constant. Sum of the constant is n times c. So the 5 times 0.02. You see that? So if you simplify this, you will get 0.016 times. So n is 5, right? Again. So what you do here is, but do you know that because the summation formula that starts with 1, right? But here we are starting from 0. So what do I do is I plug in 0. If I plug in 0 here, you will get 0. But here if I plug in 0, you will get 0.02 because there is no I. Okay. So here it starts from 0 or it starts from 1. It does not matter. You will count how many are there total. But here you don't have to worry about 0. Why is that? Because the first term is 0. 0 will make it 0 square. The second term will be 1 square, and then third term 2 square, like that. So you will write like this: summation I runs from 1 through 4 and then I square plus this is 1, right? So why I did I 1 through 4? Because when you plug in 0 and here you will get 0. That's why I can start from 1. Okay. So 0.016. What is the formula? Here there are only 4 terms, right? 1, 2, 3, 4. That's why 4 times 4 plus 1 times 8 plus 1, 2n plus 1 over 6 plus 1. You see that? So this will become 0.016 times, and then what? Then you will get 4 times 5 times 9 divided by 6. You see that? Plus 1. If you simplify this, basically you will get 1.48. If you simplify, you use calculator, you will get 1.48. This is the left sum of the rectangles with taking the left side as the height of the rectangle. So how do I find out the right sum? So what is the formula for R? The formula for R is summation, right? It starts from I equals to 1 through n, right? N is how many n? N is 5 here. You see that? So the left sum starts from 0 through 1 less than the number of rectangle, that is 0 through 4. But here it is starting from 1 through 5n, right? And then it is, the formula is delta x times f of a plus I times delta x. Okay, this is similar to the previous one, okay, except we start from 1 and then go through 5. So what is the value of delta x? We got a delta x is 0.2. So you write 0.2 summation 1 through 5, 0.2 times f of a is 0, I and delta x. So 0.2i. You see that? Similar as above, what do you get? If you simplify this, summation 1 through 5, 0.2, that will be, so plug in, it is similar to that one, right? Plug in f of 0.2i for x. So what you do is x equals to 0.2i. So if you do that, you will get 2 times 0.2i squared plus 1. What do we get here ultimately? You got basically, you can plug in here this thing here, 2.2 times 0.2i squared plus 1. You see that? And then summation 1 through 5, 0.2 times, this will be 0.08i squared plus 1. Okay, that's what you get. And then if you simplify this, you will get summation I runs from 1 through 5. I runs from 1 through 5. So 0.016 I square and then plus 0.0 So all of these must be 0.2, not 0.02. So this must be 0.2, 0.2. All these must be 0.2. Alright, the answer is correct though. Okay, so this must be 0.2 as well. Zero point 2, like that. Now you distribute the summation symbol. So what do you get? If you distribute that, you will get the summation. What you get there is summation I runs from 1 through 5, 0.016 I square, right? And then plus summation I runs from 1 through 5, 0.2. So this is sum of the constant. The formula says that this is 5 times 0.2. That will be 5 times 0.2, right? So that will be 1. You see that? And for the first one, you can pull that out, 0.016 out, and then find the do the I square, 1 through 5, right? What is the formula for I square? It is n times n plus 1 times 2n plus 1 over 6. So what is n? N is 5. So 0.016, and then 5 times n plus 1 is 6 times 2n plus 1 will be 11. You see that? Over 6, and then plus 1 there, right? So what do you get? If you simplify this, you cancel 6 and 6, and if you simplify this, your answer will be 1.88. So what was our left sum? The left sum L was 1.48 and the right sum R is 1.88. But you know that when you approximate the area under the curve, right? Sometimes you take the left side as the height, sometimes you take the right side as the height. You see that? This is the rectangle with the left side as the height. You see that? And sometimes you take the right side as a height. When you take the left side as a height, and if you sum all those areas, so it will give you approximate the area under the, it will approximate the area under this curve. But it will miss some of these, right? You see that this part, this part, this part is missed. Similarly, if you take the right side as the area, if you take the right side as the height, if you take the right side as the height, okay, for example, for the first, it is the, this is the total area, right, of the first rectangle, and this is the total area of the second rectangle. This is the total area of the third rectangle, and this is the total area of the fourth rectangle. If you do that, it is overestimating the area, meaning it will give you the more area than the actual area of the rectangle. So both of them, sometimes the left area is smaller than the right area, sometimes the right area is smaller than the left area, because it depends on how the graph of the function is, right? If your function has this type of graph, then the left area will be like this. You see that? So the left area, taking left side as the height, it will become like this. This is the left area. This is the left area for that, and another one has, this is the left area, right? But if you take the right area, it will be like this. You see that? This is the right area for this first rectangle. This is the right area for the second rectangle. So it depends. Sometimes the function has the left area bigger than the right area. Sometimes the right area is bigger than the left area. But it looks like none of these left area and right area is giving the exact value of the area under the curve, right? Sometimes what we do is, we call the mid area. What we do is to take the height of the rectangle, instead of taking the left area and the right area, okay? Instead of taking the left area and the right area, what people do is take the midpoint and then take the height and then think that as the area of the first rectangle. Although the area of the total area is like up to here, right? And for the second rectangle, take the midpoint here and take that as a height and then complete that like this, okay? So this is the area of the second rectangle and so on. So sometimes this gives you the better approximation of the area. So basically it will have less error than the mid area will give you the better approximation, okay? For the mid area, take the midpoint and then take the height and the midpoint and take that as the height of the rectangle. Okay guys, so sometimes we do that, but in all these cases we divide the rectangle into equal pieces, right? So equal piece, delta x, delta x, delta x, like that. Okay, So in the next section, you will see the Riemann sum. Instead of left sum and right sum, we take the Riemann sum, meaning that you don't have to have the equal width of the smaller rectangle. We can have the bigger sum width or bigger sum width or smaller, which we don't cover in detail because of the time, okay? But I will try to go over very quickly on that. Okay, so this is how we find out the left area and right area of a area under the, for the area under the given function. Okay, guys? Thank you.